Okay, I just realized that I use I, J, and K here. But I'm sure you know what it meant. Okay, that's how you use it in maths. But ideally, I should have used A subscript X, A subscript Y, and A subscript Z with a top hat. But it's not going to make any difference to solving this problem. These questions, you're given a vector field A, and you're asked to find the curl of A. So I'm going to go through that. So curl of A, we said that is equals to our delta operators cross products with a vector field A. And then we said that our delta is equals to del over del x unit vector x plus del over del y unit vector y plus del over del z unit vector z. So cross products, we can solve that from determinants. So the first row, so my vector A and my delta, they both have the same vector space, so there are three. So we have unit vector A, unit vector x, unit vector y, and unit vector z. So the first row is the unit vector. Second row is my delta operator, my del operator. That will be del over del x, del over del y, del over del z. And then the last row will be my a. That will be y to the 4 minus x squared z. And then x squared plus y squared. And then minus x squared y z. And then you can solve the 3 by 3 determinants. So we have unit vector x, and then minus Okay, then you can solve the 2 by 2 determinants. So this 2 by 2, that will be equals to del y times minus x squared y z. So basically differentiate minus x squared y z with respect to y. And then minus del over del z x squared plus y squared. Follow so far? Okay, so the next one, minus unit vector y del over del x minus x squared y z minus del over del z y to the 4 minus x squared z. And then the last one plus unit vector z Okay, that will be x squared plus y squared minus del over del y to the 4 minus x squared z. And then the rest will be doing your partial derivative. Okay, this partial derivative with respect to y, so we treat x and z, assume they are constants. Okay, so you get minus x squared z. And then this one, with respect to z, so there's no z there. So what's that derivative becomes? 0, correct. And this one will be minus 2x, y, z. Then minus x squared for this one. So y to the 4, there's no x there, so that becomes 0. So minus x squared z. With respect to z, that will be minus x squared. And then this one, that will be simply equals to 2x. And then this one, minus 4y cubed. So, clean it up. We have minus x squared z of unit vector x. Yes. Which one? Which unit vector? Y. Okay. This one? This one? The second one. Oh, is it?
Go back to the previous slide. There is a square.
Okay, z squared, is it? X is z squared. Let's check. Okay, there's a z squared here. Okay, so let's ignore this because I'm that far away. So just treat this as a new question. Okay, we'll finish this and then we'll go back to that questions, okay? Okay, so this is the solution for this particular problem, rather than the one I gave earlier. Okay, for the tutorial that I gave, the solution should be minus x squared z. So that's the same, plus 2xy z minus 2x z and then plus x to y and this one is for a equals to okay, which is the original questions, and this the solutions. Yes, it's 2x, yeah. Two x minus 4y cubed. Okay, that's the correct answer. Yes. For the one I gave earlier, the solutions should be, for the z component, should be 2x minus 4y cubed. Okay, so what I've shown you is that mistake can be very easily made. Okay, so steps is very important. So even in your assessment or even in your exam, so it's vital that you write down the steps. So if you make error like that, you're still going to get marks because there is steps to show what you know. But if you don't write steps, you make error like that, just write the answer, then I can't tell whether you know how to do it or you just simply write me equations. Okay, so when you make a mistake. So steps is in engineering is quite important, especially in exam, to show what you know. So don't skip steps when you answer questions in assessments. Okay, next one. Okay, hope I copy the questions correctly this time. Can you actually see it from the back? Is it too small or? Okay, better? Unit vector x, unit vector y, and then unit vector z. Del over del x, del over del y, del over del z. First one, z exponential 2xy. Two x z cosine y, and then x plus 2y. Okay, so now just solve the 2 by 2 matrix or 2 by 2 determinants. So the first derivative with respect to y, that will be just 2 minus, with respect to z, that will be 2x cosine y. And then this one, with respect to x, that simply equals to 1. And then this one with respect to z, that will be minus exponential 2xy. And then plus with respect to x, there will be 2z cosine y. And then this with respect to y, that will be 2x z exponential 2xy. Okay, so that's the solutions to the second one. Okay, any questions? So you know how to solve curl of a vector field? Yes.
Do we have to change the IJK into the A with the F?
Ideally, I should have given you in A sub x, A sub y, and A sub z. Okay, but if you solve it in I, j, and k, that is fine as well. Okay, it's just that I want to be consistent with this module, so I just change it to A sub x, A sub y, and so forth. Okay, so if you have already solved it in I, j, and k, that's fine. Okay, divergence, what it is? That's equals to your del dot with A. So A is equals to x squared y minus x, y, z y, z squared okay, so divergence and that's equals to del over del x minus or plus del over del y plus del over del z y z squared. So this partial derivative, that will be 2x y minus x z plus 2y z. Okay, so that's the solution to this divergence. So how do we get from here to here? Why is it just this part remains when you multiply that two functions or two brackets? So if you do your normal multiplications, okay, so you have, I just take this, why is it dot products? just multiply elements or elements by elements. Okay, so if you times out these brackets, you get ax times ax plus ax ay Okay, so if you multiply out this multiplication here, so this is my dot products. So there's all the elements you end up with. Okay? So we know that dot products A dot B is equals to A magnitude of A times magnitude B cosine theta. Okay, so my coordinate systems, this is my AX. So AX and AX, they are aligned, so they are 0 degree apart. So cosine of 0 is 1. So here I end up with 1. AX and AY are orthogonal. They are 90 degree. So dot product of that, cosine 90, there will be 0. So this is 0. Same thing, X and Z is also 90 degree. So that is 0. This one also 0. This also 0. I miss out one term, I think. There should be A, Y, dot, A, Y. And this will be 0. And this is 1. This is 0. And this is 1. Okay? So that's why dot products of two unit vector, you end up with 1 plus 1 plus 1. So it's 3. But in this case here, my unit vector has either a function in front, or in this case here, there is a partial derivative in front. Okay, so this times this, my unit vector times unit vector, that will be equals to 1 multiplied by del over del x into x squared y. Okay, so that's how it come about. Any question on the divergence? Okay, quite straightforward. So the second one, the solution that I have is 4xy minus, no. Okay, the solution that I have is actually just 0. Okay, so the second one, this one, the divergence of that is equal to 0. So you can go back and prove to yourself that's the case. Okay, I will stop here.